Some people call you the father of DataOps.
Oh yeah, one guy called me the grandfather of data ops. That hurt.
Yeah. I'm just thinking like about the introduction. Should I use that, or you prefer I
You
do
call me
not?
whatever you want. Yeah,
Okay.
the
Okay. So
grandfather,
let me.
father. Uh, I've been doing it a while, so yeah, whatever term you want to use.
Okay. So I'll do a quick introduction and then we'll start. So hi everyone, welcome to our event. This event is brought to you by Data Talks Club, which is a community of people who love data. We have weekly events. This event is one of such events. If you want to find out more about the events we have, go to the description. There is a link. Click on this and you'll find out about all the events we have. We have quite a lot of them. Check it out. If you, for some reasons, haven't subscribed to our YouTube channel, do it now. You will get notified about all our events. And we have a lot of amazing events like this one today. And join our amazing Slack community where you can talk to other data enthusiasts. During today's interview, you can ask any question you want. There is a link, a pinned link in the live chat. So just click on this link, ask your question, and I will be covering these questions during the interview. So this week we'll talk about DataOps, and we have a special guest today, Chris. Chris is the CEO and head chief at DataKitchen, and some people call Chris the father of DataOps. Maybe he will tell us why. So welcome to our event today.
No, thank you. Yeah, thank you for having me, and I'm happy to be here and tell some stories. So get a blanket and some hot chocolate, and hopefully you won't fall asleep.
Okay, I'm sure nobody will. So before we go into our main topic of DataOps, let's start with your background. Can you tell us about your career journey so far? And maybe you can also mention why some
Well,
people
I
call you
guess,
that.
yeah, that's fine. So what's the headline is sort of old data nerd. I guess that's the headline. I grew up in the central part of the United States, Wisconsin, where there's a lot of people of German heritage, and my last name Bergh probably is evidence of that. And so I worked my way through college, and then I spent 15 years kind of building software at companies like NASA, a lab at MIT, some internet startups, one Microsoft, and then I sort of got the management bug. And then about 2005, when my kids were young, actually, I think my son was 7, I was like, oh, I need a break. I want to be home by 5. I'm a big software guy. I'm going to do this data stuff full time because I'd done a little of it. It'll be easy, no problem. And it wasn't actually. And so I managed people who did data science, data engineering, data visualization, and my life was bad. It was just things were breaking left and right, and we couldn't go fast enough. People always had more insight questions, and my team wanted to innovate. And so, in some ways, I've been on trying to solve that problem now for the last many years, and so in the interim, I think I've really come to realize that the problem is less, because as an engineer who codes and has written a lot of code, it's less about the production of code and more about the sort of processes around the building of the work. And so, and really, it's kind of that realization back in 2005 and 2006 that I ran a factory, that data came in on one side, and there were places where that data was assembled and models were applied and results were added to it. And how to run a good factory was not something I knew as a software engineer. And so I had to go back and read about industrial process automation and Deming, and lean techniques.
So it
And
was an
then,
actual factory. It wasn't a metaphor.
no, well, it was as a metaphor, yeah, but like in some ways, I think when you have a lot of data pipelines in production and you have customers who will yell at you when they're late or when things are wrong, having a good production process becomes really important. But then on the other side, so you run a factory, so you have a hard hat, but on the other side, you really run a software team, because changing the work that's in production, the rate at which you can change, the cycle time at which you can change is really an important determinant of customer success. Because you don't want to like have an idea and then spend 3 months working on it and then have your customer go, That's not quite it. and so you run a factory, which is sort of be a hard hat, but you also run a software team that has to be agile. And so how do you do both those things at the same time? Kind of deal with sort of hipsters and hard hats with cycle time and error rates in production. And that's, I think for me, we started this company about 8 years ago, and those issues were really sort of burned into my brain as a leader, like solve those. And so no one kind of understood what we were talking about then, in the sense that this sort of idea of automation and lean techniques and DevOps was really very kind of out there. And so we had to talk and make a word for it. We called it Agile Analytic Operations for a while, and DevOps for data science. And then we, in about 5-6 years ago, we picked DataOps. We made a list and picked DataOps because it was the shortest possible name. And it had been in use before. And we wrote the Wikipedia article and a manifesto. And over the years, we've had to write quite a bit and talk about it, just to get this idea, that the how your team works rather than what you do. And I mean, what you do is cool, like model selection or data transformation techniques and visualization. Those are all really good things. The basic idea of DataOps is if you build a system around that automates a lot of the monitoring, deployment, collaboration, your productivity goes way up and your customers are much happier and you end up doing better work.
So is this the essence of DataOps?
Yeah, it's the essence. Yeah, it's about the system. It's about how you do things rather than what you do. It's about the assembly line and not the individual assembly.
So is it more about tools or more like I don't know, with the approach or both? Maybe you can tell us what DataOps actually is. So you said it's a system that automates like all this monitoring that helps people be more productive, so people don't need to, I don't know, worry about broken pipelines, and when things get broken, they, know how to fix it, right?
Yeah. So I think it focuses really on 3 things. One is lowering errors in production. And so what do I mean by that? I mean that the value, if you follow data from its source all the way to where it creates value and all the different tools and systems, the metaphor I use for that is a factory, right? Where you take it and put it in you put it in a bucket store, you put it in a database, you aggregate it, you run features on it and build a model. It gets cached in a report, it's governed, all those pieces that go with it. And that journey that data goes on, metaphorically, is a factory process. And you want to have a factory that produces good things, right? That has of high quality and low errors. And so for us, we think focusing on error reduction means you improve customer data trust. And if you notify about problems, and that's really an observability problem, if you want to use a DevOps term, or a monitoring problem or a data quality problem, the industry hasn't quite named what it is. But really, it's like, check the stuff that you're doing. And an example of that is about a month ago, I talked to a guy who's one of the leaders of a data leader of one of the biggest companies in the United States. And he got a call from the CEO of his company saying a report was blank. And it took it took 26 people out of his team of hundreds to find the problem. It took him 6 hours. And it was a dumb problem, like a blank field, this, that. It's a dumb problem. But the point is, you should know if the results work. And another story I tell is in 1990, my first job out of graduate school was to work at NASA Ames. And at the time, NASA had put the Hubble telescope in, and it was blurry, right? It didn't work. And no one had sort of looked through it before it launched. Like, no one had said, oh, let's go look in that house next door. And I think that's very true of our data and analytic teams. We sort of put things in, we do all these little individual stuff and it doesn't work. So error rates in production, and then cycle time of deployment, how fast you can get new models, new data sets, new visualizations kind of from your mind into production. And it's both velocity and risk. And And then the third part is really focusing on team productivity and reducing the amount of meetings and collaboration. And so, and then the last is sort of a principle that these processes that you do, error rates and cycle time and productivity, they're measurable, and you should measure them and you should work on them. And so, which is surprising that we work with people who are very analytically oriented, but these incredible, important metrics on their team success, like how much work is your team doing? How often are things breaking? How fast are you getting new things into production? Those are really important metrics. And overall, it's a very value stream focused. So it's not so much about data science or data engineering. It's really about this lean principle that you always optimize the whole and not the part. And so, and the reason for that is, like, obviously in manufacturing, you take an individual workstation and you make it super powered, there still could be a bottleneck later on. And the same thing applies to data and analytic pipelines. You could have the best model in the world, but it's fed by bad data, or it doesn't get in the hands of production. And so over optimizing a part, both from a throughput standpoint or the amount of insight it generates, seldom works. And so that it's a very holistic discipline. And so and that also drives productivity. So in some ways it's an idea. And, we have a company and we have software that accelerates that idea. But just like lean manufacturing is an idea, or DevOps and software development's an idea, there are tools to accelerate the implementation of that idea.
Mm-hmm. So correct me if I'm wrong, maybe. So you said the focus of DataOps is on three things. So the first is you want to reduce the number of errors you have in production. So we can think of this as a factory line, and then like there is some, assembly line, and then we want to monitor that everything is fine there.
Yeah, you want your factory to produce a Mercedes and not produce like an American Motors car from 1975.
Then the second thing is reduce the cycle time of deployment, right? And then the third time is team productivity should increase, right? And I imagine that if you want to have like an effective factory, right, it's not only about the tools and then monitoring system you have, but also how people operate there, right? So it's both about tools and the processes, how exactly people use these tools. Is it correct?
So cycle time, error rates, cycle time, productivity, and then the last thing is measurement of those things, because you can't improve what you can't measure. And so
did you say that you didn't know how to call it? So I think there were a few names: Agile analytics operations, then DevOps for data science. But then it was actually you who came up with this term.
There was the term. There's a company in the United States that has been using DataOps since the 80s. And so I think of the term. I guess my thought was we're trying to get an idea across. And so we needed a name for that idea. And I'm pretty arbitrary on what the name is. So I felt the shorter, the better. And so we could have called it Tom and I would be happy, but the idea has to be hooked up to a name. And so we needed to, and so people asked what, and the reason is when we went to conferences and we were wearing chef's hats and people were looking at us like we were aliens, and because no one understood what we were talking about. And it's frustrating to go and like work for years and build software. And then like, no one goes, what, are you an ETL tool? Are you a data science tool? Do you build a data lake? I'm like, no, we do this thing called DataOps. He goes, what's that? And I think at that conference, it was like a Strata conference, a big conference. We like talked to hundreds of people and had all this. It's very frustrating. And we talked to finally one guy, and I'm describing it to him in these terms. And then he goes, that sounds a lot like DevOps. And I was like, yeah, it's just DevOps for data and analytic teams. And he goes, oh, that makes sense. You mean people don't do that already? I was like, no one. And that's the problem. Like people there's a sense in, if you come from a software development background, that automating and testing and monitoring and the processes your team works on are really important and worthy of investment, right? And they're not just for lesser beings. It's like, if you can get those right, and actually what's happened in software, the team percentage of people who are allocated to, instead of doing the work, working on the processes and automating around it, is upwards of 25% of the whole team. And their pay is actually at sometimes higher than the people who are actually doing sort of JavaScript or, building a web backend. Because the system, you get the system right, actually, it allows you to make a lot of changes quickly. And so if you look at a data and analytic team, 1%, 2%, people are doing it on weekends. It's like, hey, maybe it's not seen as kind of worthy work. And so that's sort of partly my mission, is that work is actually really worthy, and you own the processes that you work on and you can control them. And if you don't, what happens is your life sucks, and it's not good. And I've suffered for many years, and I suffered in two ways. One is I was a bad manager. I blamed people instead of the system, because if you actually read Deming and the lean principles, 95% of the time, it's the system or the process you work in and not the person's fault. And as a leader, guess who owns the process that people work in? You do. The leader. It's much easier to say, oh, this person sucked, I'm going to fire them. They're letting us down. And so I did that. I'm ashamed, actually, that I did that sometimes. I think and it's partly also when you are in a data and analytic team and your customers are rolling their eyes because they ask you something simple. You say it's going to take months, or your data providers are giving you crappy data, and you're just caught. And it's not a fun job. And I think there's a lot of evidence of that. Like, Gartner says 60% of projects fail. There's the model. Most models don't make it into production. There's our studies of the amount of errors that are happening. And we even did a survey with data.world of the psychological state of data engineers. And it was actually a significant, we got 600 responses. So it was a decent, statistically relevant survey. And 70% of them said their job was so stressful, they wanted a therapist to go with it. And I kind of wasn't surprised. It's not a great job, because you're sort of, once you get something working, you struggle to get something working. Then people ask you more and more and more. Mm-hmm. And then things break left and right. And then, then you're like, this sucks. And then you quit and take another job. And that's why
you do the same thing, right?
Yeah, you do the same thing again. And that sort of, that sort of complexity makes, and complications make your life not fun. And I just don't think we need to live that way. I think there's a better way. And I think it comes from this idea that we as people own our process, and we can take control and just don't have to suffer. And we just don't have to live that way. And so, because I think it actually ends up hurting people's psychology. When I was my 42nd birthday, this was in, 2007 or whatever, one of my data engineers had his 24th birthday. And so he came in on a one-on-one, and we're talking with him, and he started crying because he just felt bad. I can't go fast enough. Things are breaking. My customers are yelling at me. And he was just he's a really good guy. And I felt like crap, because here he was taking it very personally. And actually that happens to a lot of people. And so we have a backpack full of tasks. We've got data providers who don't care. We got systems that are funky, and we're just told work harder, and that's not, I just don't think, I think if anything, the idea of DataOps is about taking control back and saying, look, you can, and saying these methods that worked in manufacturing, these methods that worked in software, let's just steal them and apply them to our jobs. That's it.
So you have to own the process, or the process will own you, right? And then
Exactly.
all these funky systems, bad quality data that will keep you awake at night, right? You don't want to have that. You want to be in control of these issues. So you need to take
Exactly.
control of that. And yeah, so you said that having these processes are important. So we need to work on these processes and automate them. But how do we actually do it? So let's say I'm a data engineer. I just joined a startup and I need to build a data pipeline because the management wants to have a dashboard. So I do this, I don't know, I do it in Spark or whatever, it works, and then the management, of course, is satisfied, and then they start giving me more and more and more tasks. So I don't have time, let's say, to just slow down and then take control of this and make sure that it's not like duct tape and I don't know what not, but actually like a solid thing that does not wake me up at night. So how do I go about, defining these processes and automating them?
Well, I think it's the definition of success and the definition of done, right? So I think there's definitional questions. And so what running towards making your customer happy and being a hero is not in itself bad. So that the sort of heroic act of bolting together Spark queries and dashboards and however you want to do it, right? And integrating data and having the higher ups go, oh, thank you, that's great. And then 10 follow-up questions and you're working the weekend. And then somebody changed something on the data feed and you're fixing it on Sunday. And so like, I think that's not bad, but the saying of what is good look like. And what good look like is if you've done something that you can run it and it will tell you if something's wrong while it's running. And you'll be able to make a change somewhere and you'll know if there's a problem in it. And you can also hire a 22-year-old who can start working on it and be able to make a change quickly. And so what is done and what is good, we have to talk about, right? Because like a lot of times we think done means our customers are happy and then it's on to the next thing. And the discussion with the customer comes is like, look, it's not done because of those situations. I need to do more. And so we need to set up a system to handle this complexity. And so I think that discussion was like, I was a software engineer in 1996. And I was like working on live websites. Like it was a very early sort of Facebooky website. We had 4 million people on it. I was like restarting the server, kicking people off. I was like there late at night. And that was cool. I was like, hey, you're a hero. And like, do you want big companies doing that nowadays? No. And so I think what's done and what is good, I think you have to have a discussion with people. And also it becomes a question of trade-offs. Like, okay, I can go really fast, but I'm building some technical debt. The next sprint, can I have some time to reduce that? Or else I'm going to be able to do less in the future, right? Can I have some time to refactor? And so can I have some time to write some documentation? Can I write some governance documents? We want to hire more people. So I want to put in more automated tests and more automation around it to make it easy. It becomes a discussion of time allocation. Because if you're in that situation where your value only comes from the insight you've generated and not this discussion of it just becomes a harder life because you get buried and then unhappy. And then, I've seen it, people quit. And a lot of people have entered the data and analytics field in the last 5 years. And actually there's a lot of unhappy people. And so it's because of this situation.
Okay, and how do we, so in this case, I think you partly gave an answer to that as a data engineer who just developed this Spark pipeline and put together like some stuff on a dashboard. Do I immediately go to the management and show that? Or I wait a little bit and then maybe think, okay, is it done? Is it ready to be shown? And then maybe, think about processes, think about how can I make sure that this thing is actually reliable? So at what point do I go to management and say, okay, this is ready?
DataOps is all about balance, right? Between heroism and fear, right? And one way to do it is to have fear and sort of Say, I'm not going to show it to people for weeks and weeks while I do all this stuff.
Mm-hmm.
And
I can see
that's
how
also,
that might end up not really good.
that might not be good, because why you may actually, all that work that you're doing may actually, you may capture the requirements wrong.
Mm-hmm.
Right. And so it's really like a lot of things in life, it's about balance between heroism and fear. And so I do think you should get early feedback from your customers. And I think you should tell them, look, this is, I'm giving this to you. I haven't checked the data perfectly. I haven't automated. I haven't tested it. It's not in version control. This isn't production ready yet. And so I've got some technical debt that I'm going to have to, and because they may, you don't know, that may be good enough. And then they're on to the next thing and they want you to throw it away. Or they may have 6 more things that are based on it. This may be the cornerstone that you can build a whole infrastructure on. And so you don't know what's in your customer's head. And that's okay, right? It's okay to be humble and iterate your way into really understanding what your customer wants. Because if, like I've made this mistake, you really, you have a lot of calculus, graduate degrees, man, I'm really smart. My business customer drank beer and went to business school, and like I got to work for him, and you're kind of pissed off, like, man, I did all this calculus, but the reality is they know a lot of things, right, that you don't. And so we happen to have this strange talent of high abstraction, putting data together, and we like our beer, but we're not good business people. And so I think giving them early bits of what you've done helps, and making a dialogue with your customer on what you need to do is really, and so partly it's like our tendency as technical people is to build very complicated, these sort of crystal castles. Like, I stopped coding 5 years ago and I miss it. Like I want to go and like, partly sometimes I like have to stop myself because it's like, I want to go off for like a month and code because it's really fun. But like, but I've learned that like, if I do that, I'm often wrong. And like getting early feedback, it helps. We're really just trying to maximize the amount of value you bring to the organization. And that's what really matters. It's not infrastructure. It's not deferred value, it's value.
And I think this is one of the principles of, you mentioned this lean approach, right? So in lean, I think there is a book that called Lean Startup, right? So there you don't do that. You don't, close yourself in a garage for, I don't know, for a year and implement something that maybe nobody cares about, right? So you actually show it to people, and then you get feedback from them, and then you iterate on this feedback. And is this something, one of the principles behind DataOps as well, and DevOps?
Exactly, yeah. It's a very, it's a very iterative methodology that's based in finding the right balance between heroism and fear, between being humble about what you know, and forcing feedback from your customers. So it comes from Agile software and the Agile Manifesto, and the DataOps Manifesto we wrote is sort of a blatant ripoff of Agile Manifesto, because it's a little, the problem with data is a little more complicated than DevOps, because we have 2 major cycles of iteration and not one. So one is your iteration with the customer on, is this data telling you what you want? And am I showing it in the right way? And then the second is you've got an iteration with the data itself. Like, is it actually predictive? Is this the right data set? And so you've got these 2 cycles of iteration that actually, because in software, you sort of build, you build an application, you send it to someone, they go, no, change this, change that. You've got one, you're really working on, can they use it and do they understand it? And we have that in data teams, but it's also like, can the data actually say what it is, statistically relevant? Can it support the story that you want the application to have? So it's a data problem and an application problem, and it makes it complicated. And also the value streams, the sort of the factory as data goes, is much more organizationally complicated in bigger companies, you have a IT team, you have maybe a data warehouse team, a data lake team, you'll have a data science team, you'll have end user business analysts, you have governance, and then over here you'll have the person who's receiving the value. And so you end up with these silos of optimization. And so if you really believe in these lean principles like I do, you need to optimize the whole. You need to optimize across all the teams. And you need to deliver that as you need to think about how, if I'm going to change one piece, its effect on the other. And so that's what happens a lot of times, is that one person who has one pipeline for the startup gets successful. They hire a data engineer and a data scientist. They have business analysts on it. They hire some more. And pretty soon you've got the data engineering team and the data science team, and you've got a couple of different lines of business with business analysts on. And then you hire someone for governance, and then you've got 3 definitions of metrics in 3 different places. And people are running around crazy trying to get stuff done, but you're still not achieving what you think you can. And so it becomes the sort of balkanization or separation of these teams actually makes people, which makes sense, but it's harder then to deliver iterative value. So, and then what happens sometimes?
Put everyone together, right?
Well, people put blinders on. The data team worries, my job is to get value up to here, and I don't really know what happens. I wash my hands. What does that data science team do? I don't know. And then the people who are doing visualization, who's taken maybe a scoring model in the data, they're like, these people are too slow. These data science people don't understand the business. I'm just going to go make this segmentation and Tableau and change it and throw all their stuff out. And I'm going to go to the raw data and bypass all the stuff they've done. And so everyone's optimizing their part. And I've run into cases where teams have spent years working on something and it hasn't gotten to production. Like large teams, 400 teams of 400 people, they spent 2 years and nothing's in production. Nobody's receiving value. And I think that's really what, I've learned to desperately want to deliver value to people who use it. Sometimes those are people using Tableau, sometimes those are business people. And if I don't, I get really worried that something's wrong. And that sort of instinct is what I want a lot of people to have. And unfortunately, it's not there, to be blunt. There's a lot of people who are like, I'm doing enterprise infrastructure and that's it. I'm building a data lake. Well, who's going to get value? I don't know. We're going to get all the data in the lake and I'm going to build it and they'll come and things will be great. And then there's the sort of techno fetishists of like, hey, we got this new tool. I went to their conference and had a great time, and this tool is going to accomplish everything for us. So if we just put all our data in this tool, good things are going to happen.
Hadoop, right? I think Hadoop 10 years ago was exactly
Hadoop 10 years ago, the cloud now, we put all the data in the cloud, good things are going to happen. It's Hadoop, it's Spark, it was Oracle before that, and cartridges, and it's a way to avoid, it's a way to defer value. Deferred value is a trap. Like I'm going to build something really good, and that's going to be generative. Is a trap that often hurts you.
So you described this picture of isolated teams, data analytics teams who doesn't care about data scientists, and then this data engineers who just create data lakes because they want to. And if we go back to that one data engineer from who everything started, so what these data engineers could have done to actually avoid all that. So we talked about automation and thinking of processes and automating them. So which things the data engineer should have automated to avoid all that, and what are the things they should have done? Not just the data engineer, right? But I guess the management also, what they should have done to live happily after that.
Well, we used to give this talk called the 7 steps to DataOps. And so I'll talk through that. So the first step is one of the first steps is take your code and put it in version control. Like don't have it on your hard disk somewhere or a file share. So, and all the code, the report, the transformations, that's one thing. And then second is write automated tests that run in production. So you're expecting 1,000 rows. You're expecting this report to have this value on, write a test to check it and monitor it. And then third is when you're changing something in development, run automated tests against that to judge regression or impact analysis. So be able to, if you change something on the back end, tell if the front end's broken in a very simple way. So it's testing, it's automating deployment, it's version control. And then a lot of times it's counting when you have problems. So if you have an error, make a Jira ticket or put it in a spreadsheet. You could go and if you want to improve your cycle time, like every week, start trying to deploy every week. And if you don't, note that. And I think those things are good. And then have this case of like, can I hand this off to someone else? Like, do I have to own this for the rest of my career here? Like, there's a lot of there's a lot of times in these data processes where, like, I got my Spark jobs, they run, and then I got to hit a button on my reporting engine to refresh. Is that a problem? Well, no. And then you get these Word documents that are these documents that say, do this on Thursday, do this on Friday, check this, and they become these sort of playbooks. And I'm sort of against checklists. I'm more of I'm the anti-checklist manifesto. I'm like, write code that automates that. So everything that you're doing in checklists, automate away, so that the system just runs without you and will tell you if something's wrong. And the next thing is you can hire someone just out of college and they can make a change in their first week and without having to talk to you. Like, that's the key.
Is this
system,
DataOps?
That's DataOps. Or is it DevOps? I don't know. Like, I don't really care. It's very focused on this sense of automation. And it's badly named. It's more like code that acts upon data operations. Because it's not really about the data, honestly. It's about the things acting upon the data.
And you mentioned a checklist, and if you have a checklist, you don't like checklists, you said, but it's probably a good first step, right, to have this checklist.
Absolutely.
Before you can. It's better to automate a checklist that exists rather than, not automate anything.
Absolutely, yeah, absolutely.
It's the first step for that data engineer before they hire a college graduate, right? To actually
because you want to be able to take a vacation, right? You want to have weekends off. So writing a wiki page that says, here's how you operate this thing is good. And then having that discussion with your customer saying, look, this is, I know this is taking 10 minutes a week, but if I quit, you're going to be stuck and no one's going to be able to do this, right? Or we want to hire some more people and you want me to do more things, and I'm spending 2 hours a week on this production stuff and I should be spending 2 seconds, or I should be spending no time and just have an email come. And so I think that is the sense that this idea that you're automating and also that you're running towards errors. So inevitably, like, data systems break, like that's just the fact of life. And so what you want to do is, when you have a problem, you want to find out where it is as fast as possible and automate the fix to that, a test and automation. And then that's a good thing. And so some organizations end up in shame and blame culture where errors happen and people don't want to talk about it. That's why I think counting your errors is important and tracking them. And I think there's a lot of organizations who have very poor data quality. They're missing their SLAs. No one trusts the data, but they're claiming great success. It's like, well, and it's like, no, it's not working. Like, maybe you should just have a report that actually has those things in. So anyways, is that helping?
Oh, And I guess one of the things you mentioned, which is key here, is as a data engineer, that only data engineer, you don't want to be indispensable, right? So you want to be replaceable, right? Because you want to have applications. And if you're the only person who knows how the system functions, then maybe short term you're good, like you can ask for a salary raise because they're not going to fire you. But long term, right, this is not really good, right? Because you want to have vacations, you want to have, to relax on weekends. So you actually want to be replaceable, right? And all these things that you mentioned, like automating checklists and like all the other things, like they really help.
Yeah, and I think it's not wrong emotionally to want to be indispensable. Like I spent a lot of my 20s wanting to be indispensable on a software team and wanting to be the studly guy who built the cool thing, right? And get the praise from other people because I was good, and I was like, I'm going to build the cool thing. And that's not wrong, right? It's normal. But yeah, you don't want to build such complexity that you have to own it for the rest of your career or no one else can take it over. And, we have software's developed terms like technical debt. My favorite term is hairball, like a big hairball of stuff. And like from a cat, like a cat throwing up a hairball. Like, I actually think that that's sort of true. Is like you can very easily create a hairball that no one else can untangle. And your definition of what's good and what's done has to change. You're not done when you've created a hairball. It's not good. And so I think I'm also think when other people do that on your team, you have to go, ew, you just, I know all the business people are loving you, but you just coughed up a huge hairball. And like, that's not good. You're not done and it's not good.
Do people like you after they hear it from you?
I think there's nice ways to say things.
Yeah,
I think
okay.
there's business language like, let's talk about what done means and let's talk about what good means and say, okay, and yeah, you did this great, but you're not done and it's not good because it can't be handed off because it's not in version control. Let's write it down and let's agree on what done and good is for our team with our customers. And I think there's methods that you can go, I'm being facetious on the emotional stuff, but like, I do find the sort of almost as a manager and a leader, I've had to publicly praise and privately criticize people who are heroes. Like, hey, you worked all weekend, fantastic. And then like, okay, you worked all weekend. Sometimes we have to do that, right? Sometimes you do have to work all weekend, but that should be rare. And sometimes you do have to create hairballs, and that's okay, right? But like, you shouldn't do that 95% of the time.
Mm-hmm. And all the steps that you described that this particular data engineer could take to improve the system, they don't seem to be that difficult, that complex. Like, okay, put the code in Git. I think everyone is doing this. I hope. Then add tests. Okay, this step is a little bit less easy because nobody likes writing tests, but then it's doable, right? And then integration tests, you want to be certain that your system runs, and then I don't know, automating deployment. This is actually fun for a data engineer to figure out how CI/CD works and then implement that. So as a technical person, I'm sure they will love that. So it's not I liked playing with GitHub Actions recently. I didn't know how to use them, so I spent like a weekend figuring this out, and it was fun, right?
Yeah.
So all these things that we talked about, they make sense and they're implementable. But why do not everyone is actually implementing them? Why do we have this, all these problems that we talked about? Why do they still happen?
That's a good question. So I think there's a couple of reasons. One is the writing. There's some people who are on the journey. They do GitHub Actions and they write a couple of unit tests against their Python code, and then they automate they automate instead of manually deploying steps to steps. They use CI and CD. They have some unit tests, and then they still run into problems, right? And I think So it's partly DevOps. They're sort of having this model of, oh, I use Git, I'm doing DevOps, it's good. But partly like, how do you actually prove that things work? Like what's provable that a data system works? And then how do you optimize? How do you have the whole system as opposed to just your part? Those two things are hard for people. And so number one is like, to prove data systems work, you have to pour data into them. Like you have to run them with data that's realistic. And sometimes in a startup, maybe you're dealing with marketing data, you can just run the whole data set over again. I'm a big fan of more functional data systems where the raw data is immutable. You can run it from, cloud resources are cheap, disks is cheap. If you can run your whole system from start to finish every time, and so I would say that data engineer in development should have the raw data immutable and just run the whole thing, the Spark jobs, the visualizations, and make sure that's you can prove it, and then have that be the new version of production. And so other ways, if you're deploying, so that's the end-to-end's a challenge. The definition of what's a good test, what's a good data test is a challenge. Getting good and accurate refresh test data that fits GDPR is a challenge. Sometimes actually doing the automation of environments. Like I want to build, a GitHub action means, so if you've got a GitHub action, well, what proves that development system works? Well, you've got to have test data. You've got to run your system end to end against that test data. So that means you've got some hardware, disks, startup, shutdown. You're doing some DevOpsy work. And so, that's, none of that stuff is doable. None of that stuff is not doable. I'm just saying, it's work, and it's really important work, and you shouldn't just devote 1% of your time to it. You should think about 15% of your time on that. And that may seem like a lot, but it's not. It's actually, you end up, companies who do that, they end up doing more work. They actually get more done. And so you're stepping back to do more. And so that's, I think, conceptually, I think there's still some gaps in what people think on the application of DevOps principles to data and analytic systems. I think there's still some gaps in optimizing the part versus the whole. I think there's some gaps in environments. And I think there's just gaps in leadership, honestly. I just don't think that there's a lot of data and analytic leaders they don't get it yet. And that's sort of why I talk to people. And I think it's still early. I think I used to run software teams in 1999, and I could ship software every 3 months, and I was hot shit. Like I was good in 1999. I ran a team of 30 people. We could ship software every 3 months. That was like good startup best practice. Right now, I would not get a job. Like I would say, I know how to ship code every 3 months. People would go, what? And I'd say, you can't do it any faster. And then people would go, no, you should be able to press a button, right? And have the whole system. Actually, when someone does a Git commit, the whole system should tell you if it's wrong. And why? Well, people have learned what's good and what's done is a very different set of ideas. And that's what I want to have happen in data and analytic teams.
Mm-hmm. Any tools you can recommend? Like you described all the difficulties that the teams face when implementing all these DataOps principles. So it's not just about, having a CI/CD configured, but you also need to think about this integration test with data. The data has to be, comply to GDPR. Like how do we actually run these tests on data? Are there tools? I know that there is a question. So for example, do we use things like Great Expectations, or are there any other tools that we can use to make these steps easier?
Yeah. A lot of, I was actually really, I think DBT has tests, Great Expectations, a test engine, and a lot of, and you don't really need it. You can write tests in a lot of ways pretty simply, right? You can do row count checks, and you can do, write these expectations and write SQL queries to do the tests. And so the whole idea is that those tests themselves are done automatically, that they're in version control, that they live fairly close to the code that you're running on, and that they're run during production, and that they're run during, all those tests are run during development. And so I think that's it. Is like, think of 10% of your work should be developing automated tests. And like, if you're a software engineer and someone wrote, 500 lines of software code and there were no automated tests, and tests are different. Like it's not, unit tests are nice, but you also need system tests. You need to run the whole thing from end to end. And sometimes, like when we first started the company, we had a small customer, and I was the data engineer for it. And I was sort of writing our product and doing data engineering. And so, there's the inevitable problems, and I just write more tests, and our product helped us do all that, right? So that's sort of why we're a product company, why we build a product, because we want to make those automation things easy for people.
Yeah, and there's another question. So what are the differences between DataOps and MLOps? Are they the same thing or different?
So there's two answers to that. One is, as an engineer, no, it's the same freaking idea. It's just DevOps and Lean applied to data. And so you call it DataOps or MLOps. Gartner's been using this term XOps. So I don't really care. The principles matter, not the moniker, right?
When I say this, people are rolling their eyes and say, no, MLOps is different because it's about machine learning.
Yeah, you're not different when you do machine learning. I mean, it's cool, right? But like, it's code that's acts on data, just like ETL code, just like Viz code. You're building an application. So it's, you have more investigating. Those two cycles are a little bit different. But yeah, I mean, I've gone to conferences and had data scientists basically tell me I'm wrong, that data science is different, and it doesn't apply. These sort of process DevOps principles don't apply. And like, no, they don't apply directly. Like, you need to adapt the concepts to models, and you could call that MLOps. You need to adapt them to data science and visualization. I use the term DataOps to encompass, because I think the data, the model, the visualization, the governance, I think of those as a unit, like, and optimize the whole of that, not just your part. And so do ops on all of that. And if you're gonna, like, think of just something really simple, like I add a new table to a database, right? Really simple. So I want to add a new table to a database. I got to change how it's maybe joined to another table. Maybe that ends up as a new feature in the model. So the model's got to be retrained. And then I want to take the result of that and change my visualization. And then I've got to change my data catalog. So the principles say automate all of that, right? Put that all in version control. Deploy it all as a unit as once. The new code, the new model, the new visualization, and the new governance, the new data catalog. Like, all those things are versionable. They're all just code, right? And then in development, pour some good data in, run tests against the new thing that you developed, the new table, and run all those other tests that you've had over the years to see if you've broken anything else. And so you can't, it's a very kind of simple concept, but like, I think it does take some work to do that. And I think that's where people are struggling, because they need some automation help to help them do it.
So your position, your title is head chief at DataKitchen.
I'm head chef, yeah, head chef, yeah.
So can you tell us more about what you cook there? Is it?
I'm a suburban American man, so my cooking is restricted to grilling outside, grilling meats outside. And so I grew up in Wisconsin, so one of my favorite things is bratwurst with sauerkraut brewed in beer. That was in Milwaukee, Wisconsin, that's like and I had Braunschweiger for lunch yesterday, so I'm like, so
that's pretty typical in Germany, right?
So
you said there's a large German, like a lot of Germans live there, right?
Yeah, in the central part of the U.S., a lot of Germans and Scandinavians in the late 1800s. Yeah, and where I live now in Boston, there's not. I mean, the Germans themselves are sort of the largest ethnic group by count in the United States, or maybe they were. I don't know. Maybe it's Hispanic. I don't know now, but yeah. And so I'm a head chef just because it's fun. Our company, we're sort of 45 people. We've been around for 8 years. We're profitable, we're growing, and we're on this mission to get people to adopt DataOps, and we want to sell some software along the way. Yeah, we do. We think our software is great, but more than that, the reason I do this is I want people to get the idea and see that they don't have to sort of live in this way. And I think there's my feeling is that it's actually, I'm very optimistic. And so like the fact that you're playing around with GitHub Actions, that's fantastic. Like I just think people are getting it, right? And they're going to get there, and it's going to become common practice 5 years from now. Like, the definition of good and done is just going to switch, and people are going to go, screw this, I am not working. And there's like, I remember on Stack Overflow, there was this, Joel's had this list of questions to ask on your team.
12 questions, right?
12 questions to ask. Yeah. There's going to be that for data teams, and it's going to be very similar. There's going to be DataOps questions.
Put this together.
Yeah, it's that. Yeah. Ask these 12 questions and don't take a job if they're like that. And all those were like, all those questions were, I remember most of them were like, how much DevOps are you doing really? How agile are you? How to DevOps? And I think it's the same answer is going to come. And I think there's more people who they're going to stop and rebel against heroism and rebel against fear and say, there's got to be a better way.
Okay. So you said the cook, you like to grill data at DataKitchen. So what is the software you mentioned? Or what are you grilling?
Oh, it's a platform to automate. So we do some of those things that we talked about. So we do, we help people. I guess the first thing is we're the factory. So we allow you to plug in your data science tool, your data engineering tool, your data visualization tool, your governance tool. And then we can observe all those in production, run tests against them. We can help build environments for you. And then if you want, we could do even more. We could orchestrate all of them. And so what we're trying to do is help people where they are and where they start. And so we tend to sell, we have a different way of building the company. We're profitable. We never took any financing. And so we're trying to grow a reasonable company and stay around for the long term. And so it's actually been good because there's a lot of companies in the DataOps space who've been funded and growing. And so like Superconductive just got an enormous amount of money, and a bunch of observability vendors that they put
Monte Carlo, right? They raised quite a lot of money.
Yeah. And so that's good, right? Because they'll be able to use that money to talk about these ideas, right? And that's a really good thing. And people are going to hear it more and more, and eventually it'll change.
Yeah, we had Bergh on this podcast talking about that. So
yeah. And I think that's fantastic, right? And so my mindset is I was so far out in the wilderness talking about these things 6 years ago that like there's anyone else is talking about them, I'm like it warms my heart. And so I think it's going to be, from a software standpoint, open source, closed source. I actually think from a career path, the sort of data ops engineer is a good career path, actually, because I think people are going to need them. I think companies are starting projects, and people are getting approaches. And and for me, I guess just technically, I did enough data and analytics that like, okay, I can do models. Maybe I'm not the world's best data scientist, but I can do some. I can do some visualization. I can do some ETL. Like I can do it, but I like and those are great. But like, my perspective is the system, you get the system right, you get iterations right, and errors right, and productivity right, and measurement right. You get those 4 things right, you're going to be able to power through.
Yeah, we should be wrapping up, but there is one question. I don't know, do you need to go somewhere, or you have a couple of minutes?
No, I have a couple of minutes.
Yeah, so because I know that you have a book called DataOps Cookbook, so I see that you love these cooking metaphors. So of course, what kind of books you would have in DataKitchen. So maybe you can briefly tell us what is in this book I know this is a free book, so everyone can just go to your website and download it. So maybe you can briefly tell us about the table of contents and what people learn from this book.
Yeah, if you want to learn more, there's a DataOps Manifesto. That's 18 points, one page. There's a cookbook, which is about 150 pages with lots of pictures. And it's sort of, it's goes one level deeper on what I talked about. Like, how do you write a test? What is a good test? How do you organize a team? How do you track errors? And it's got lots of pictures and examples. And then we've got even a 3-hour sort of video with question certification if you want to do that. So we've invested a lot. And we have a second book too, if you're more of a manager and you're like, these ideas are good. How do I get my team to adopt them? Sort of how do I lead data ops from the top down? And so we have a lot of good, we spent a lot of time making sure that people have these free resources to learn and to spread the ideas.
Yeah, thanks a lot for putting this together. These are invaluable resources. I will make sure to include all these links in the description so everyone who's watching this can find them. And thank you for joining us today, for sharing your experience, telling us your stories. That is, thanks a lot for that. That's great. And yeah, also thank you everyone for joining us today, for watching us and for asking questions.
All right, thank you. Yeah, thank you for the opportunity. And to all the listeners, it was good. Hope you enjoyed the story time and stayed awake.
Yeah. Okay. Well, have a great weekend.
Okay, you too.
Bye.
Bye.
Bye.